All right, we're in 3-3, and today we're going to be proving lines are parallel. We're going to use the angles formed by a transversal to prove two lines are parallel. So basically what we're doing today is we're using those corresponding angles, alternate interior angles, alternate exterior, and same side interior to prove lines are parallel. So we're kind of doing the opposite of what we did in 3-2. So I want you to first review a converse. Remember, a converse is the flip of a conditional statement. So if I said AB plus BC equals AC, then A, B, and C are collinear. So if you want to think about it in terms of the segment addition postulate, this is what a picture could look like. Okay, I want you to see if you can do the converse of this statement. So converse, again, you flip it. So you're flipping the P's and the Q's, and you're rearranging it. The reason why that's important is because if you look again on your yellow cheat sheet, that theorem cheat sheet I gave you, yesterday, you guys wrote down that the corresponding angle postulate said that if I gave you two lines are parallel, right? If I gave you two parallel lines and said something about this angle 1 right here and this angle 2 over here, then you could say that the measure of angle 1 is congruent to angle 2. Well, that's a postulate, and this is a conditional statement. So what we're going to talk about today is if I give you that measure of angle, not measure of angle 1. If angle 1 is congruent to angle 2, then those lines are going to be parallel. We're flipping it and we're doing the converse of this thing. So again, on your yellow cheat sheet, you're going to write down 4 more postulates and theorems. First one is called the converse of corresponding angles postulate. And the postulate and theorem doesn't really matter to me, but the converse is super important. If I give you this picture and I tell you that angle 1 and angle 2 are congruent to each other, notice I didn't say anything about the lines being parallel. That's because the conclusion, what you can conclude is that the lines are parallel. So there's going to be 4 that you're going to write down. Let me scoot down so you can see it. There's all 4 of them. And again, if you were going to write this down in your notes, I would write down that the converse, we're going to use the converse to prove lines are parallel. That's the only thing you use the converse for. And I'm going to ask you again and again and again what we use the converse for. So there's 4 converses: converse of corresponding, converse of alternate interior, converse of alternate exterior, and converse of same side interior angles. The converse of corresponding, alternate interior, alternate exterior, notice that I have to tell you that the angles are going to be congruent to each other, and it just, the only thing that's different is where they are. These are corresponding angles. In here they're alternate interior, and here they're alternate exterior. Same side interior angles, remember, those are not congruent. Those are supplementary. So if I tell you that these 2 angles are supplementary, then you can prove that the lines are parallel. Okay, so what we're going to do is, the first part we're going to do is we're going to determine whether the lines are parallel. So use the given information and theorems you have learned to show that line R is parallel to line S, so that this line is parallel to this. Again, it looks like in the picture, but I didn't write those arrows. So right now, you're not sure if they are parallel or not. So if I tell you, for example, number 1, that angle 4 is congruent to angle 8, angle 4 is congruent to angle 8, can I say that these 2 lines are parallel? Well, these look like alternate interior exterior angles. So by the converse of alternate exterior angles, R will be parallel to S. So that's how I want you to write your answers today. For number 2, it says measure of angle 2 is equal to measure of angle 6. Well, we could say by the definition of congruency that angle 2 is going to be congruent to angle 6, right? So if they're congruent to each other, these are now alternate interior angles. So by the converse of alternate interior angles, then R is going to be parallel to S. Then the last one, number 3, says measure of angle 2 is 10x plus 8, and measure of angle 3 is 25x minus 3. And notice I even tell you what x is. You don't even have to do any algebra. I didn't say that they're congruent or that they're equal to each other, but what do they look like? To me, they look like same side interior angles. So I'm going to use the converse of same side interior angles. And that one said that if they add up to equal 180 degrees, then they're going to be parallel. So I'm going to plug in x. I'm going to plug in 5 for x and see that if we add them up, so this was angle 2, and here's angle 3. if I add them up, will they equal 180 degrees? Well, 10 times 5 is 50. 50 plus 8 is 58. 25 times 5 is 125. Minus 3 is going to equal 180 degrees. So since they equal 180 degrees, you have to show this work on your assignment tomorrow. Then you can say R is parallel to S. So for some of you guys are like, okay, this is really easy, Miss Broyles. I know. We're doing exactly the opposite of what we were doing yesterday. But the last thing I want to talk about is if I said, so let's add this on number 4, if I said angle 1 is congruent to angle S, does that mean that R is going to be parallel to S? That's the last question I want you to think about tonight. And again, the 4 things we learned is about the converse, and we use the converses to determine whether lines are parallel. Tomorrow in class, we're going to discuss number 4, and we're going to start proofs. Yay! Fun fact of the video, a hummingbird weighs less than a penny. What?